Hello, Chuck here again, and this is just a very quick addendum to my last video about the Commodore Pet Companion video adapter. I wanted to correct a few mistakes, and one of which, as you can see, is that the Pet Companion works perfectly fine with my Chicklet 2001. The reason it wasn't working has mainly to do with this particular board revision, assembly 320081. You might be able to see right here that these copper pads on the top of the cassette port are isolated. There are no vias here, and there are no traces making contact here. On this board revision, there are no signals on the top side of the cassette port. So no ground, no 5 volts. And the same goes for the rear port. So the board just wasn't getting any power. The solution was super easy though. The silkscreen marks this point right here to connect your 5-volt wire. But these top holes connect to the top side of the cassette port. These holes back here connect to the bottom side of the cassette port. So all I had to do was move the wire from here to here, and I would get power from the bottom side of the cassette port. It started working. Another mistake I made was in measuring this peak-to-peak voltage. As Ben pointed out in the comments, this is a high impedance input and the signal was not loaded. This should be terminated with 75 ohms, which is the amount of load that the input amplifier on a monitor would give it. So you can see we're measuring 4.4 volts peak to peak, but if I put 75 ohms on it, the signal goes down to about 880 to 900 millivolts, which is right where it should be. So the output voltage of this device is not higher than it should be. It's right where an NTSC signal should be. The other thing I wanted to do was to compare the output of this device with the output of another composite video adapter like the Petunia board that I have. We can see we're looking at primarily the horizontal refresh here, about 15.6 kilohertz. But we can also see up above that the positive going pixels, but it doesn't always trigger at the right point for that. I think if I adjust the trigger point up here, then yeah, we can get a stable trigger. So the video signal on it looks pretty much like this: your negative going horizontal and vertical sync pulses, and your positive going pixels. So this is the Petunia output. We're seeing pretty much the same thing. All the negative going pulses for the vertical and horizontal sync, but the positive going pulses are a lot higher, which explains the contrast. Looks like the Petunia board would provide better contrast. But either way, the signal is right where it should be, at about 820 millivolts. Well, that's all for now. Thanks for watching.